Hello, let me quickly share my screen as we go into the third in the series of lectures on meteorological hazards and disasters. In our first lecture, we discussed generally on hazards and disasters. And then our second lecture, we talked about meteorological disasters. Today, we'll pick one of the meteorological disasters and discuss the nature, characteristics, mode of formation, and then the impact of the disaster, the hazard. And the hazard we are picking today is cyclones. Now, as we go into the third lecture, at the end of the lecture, you should be able to describe the nature of cyclones, explain the composition and characteristics of cyclones, describe the formation of cyclones, and explain its impact on man and his environment. Now, what are cyclones? Cyclones are intense tropical storms characterized by low pressure systems, rotating winds, and organized convective activity. These winds blow in a counterclockwise spiral around a relatively calm center known as the eye of the hurricane. They have winds with constant speeds of at least 119 kilometers per hour. And around the rim of the eye, winds may gust to more than 322 kilometers per hour. These are extremely fast winds, and you should know the type of energy they carry and devastation that comes in their wake. Now, the entire storm dominates the ocean surface and the lower atmosphere over tens of thousands of square miles or square kilometers. They are known by different names in various regions. They are known as hurricanes in the Atlantic and the northeastern Pacific, typhoons in the northwestern Pacific, and cyclones in the South Pacific and Indian Ocean. Cyclones rarely develop within 5 degrees of the equator. That means within 5 degrees, that is latitude of the equator, where the Coriolis effect is weakest. Cyclones are classified as tropical or extratropical based on their place of origin and the temperature of their center or the core region. Now, tropical cyclones form over warm tropical or subtropical ocean water, typically between 5 degrees to 20 degrees latitude. And latitude, unlike extratropical cyclones, they are not associated with fronts, that's boundaries between warm and cold air masses, and have warm central core. Actually, what happens is that within the tropics, we don't have fronts, because fronts develop where there's a sharp contrast between warm and cold air masses, which leads to atmospheric disturbances. But within the tropics, generally because of the homogeneity of temperature, mostly they are warm and practically throughout the year. And in the tropics, you hardly have winter because the average temperature in the tropics is about 18 degrees centigrade. The lowest temperature, average lowest temperature about 18 degrees centigrade. While when you move up, you have temperatures as low as 4 degrees or even minus in terms of temperature. So in contrast, extratropical cyclones develop over land or water in temperate regions, typically between 30 to 70 degrees of latitude. And these mid-latitude cyclones are generally associated with fronts and have cool central cores. Both types of storms are characterized by their cyclone intensity, which is indicated by their sustained wind speeds and lowest atmospheric pressure. Now, what are the characteristics of cyclones? Now, characteristics of cyclones, sorry. One, they have low pressure systems. Cyclones are associated with low pressure systems. Let me, okay, the slides are there so you can easily see it. Low pressure areas are their centers known as the eye. The eye is often characterized by calm and clear conditions. Then you have rotating winds. Cyclones have a characteristic rotation of winds around the eye. In the northern hemisphere, winds rotate counterclockwise, while in the southern hemisphere, they rotate clockwise. Then intense convective activity. These are characteristics. Low pressure systems, rotating winds, intense convective activity. Cyclones exhibit intense convective activity characterized by towering cumulonimbus clouds that can reach the tropopause. This activity is responsible for development of thunderstorms and heavy precipitation. In your discussion of the atmosphere, we told you that the lowest level, we have the troposphere, then the tropopause, before the stratopause, then the mesosphere, and so on. So, and within the troposphere is where we have the main weather activities or meteorological activities taking place. So these cumulonimbus clouds could reach even up to the tropopause in their height, and very high convective activity. Then seasonal patterns of the cyclones. Cyclones have specific seasons when they are more likely to occur. In the Atlantic, hurricane season is from June to November, while in the Pacific and in the Indian Oceans, there are specific seasons for typhoons and for their cyclones. Then movement. Cyclones generally move from east to west due to the trade winds in the tropics. That's following the movement of the trade winds. However, their paths can be influenced by various atmospheric and oceanic factors. So these lows travel from east to west and have a well-defined life cycle of growth, maturity, and decay. A typical time scale for this life cycle, or for the life cycle of cyclone, is between 1 and 3 days. A typical horizontal length scale of an individual cyclone is between 1,000 to 2,000 kilometers. So that is all about the characteristics of cyclones. Then what are the causes of cyclone? Warm ocean water. The primary fuel for cyclones is warm ocean water. The warmth and moisture from the ocean surface evaporate and rise, providing the necessary energy for the storm's formation. Then we have atmospheric instability. Cyclones form when there is sufficient atmospheric instability, allowing warm air to rise rapidly. This creates a low pressure area at the surface. Usually, when there is normal lapse rate in the atmosphere, the warm air will rise because as you go, the temperature decreases. So there's warm air on the surface will now rise. And this rise of warm air will create condition of instability. I know later you'll be exposed to concept of stability and instability, convective and conditional stability, and so on. Then we have the Coriolis effect. The Coriolis effect also affects the formation of these cyclones. Now, Coriolis effect is the force that causes air, or rather, yes, air in motion, object in motion, to deflect as they cross the equator. And the farther away they get from the equator, the sharper the deflection of the object. So it causes developing storm to rotate, initiating the cyclonic circulation. Then you have the low wind shear. Cyclones thrive in an environment with low vertical wind shear, which allows the storm to maintain its structure and intensity. Then they also form from pre-existing disturbance. A pre-existing weather disturbance, such as cluster of thunderstorms, is often needed for the initial stages of cyclone development. Then distance from the equator. This also is related to the Coriolis force. So the farther from the equator, the stronger will be the effect that will initiate the cyclonic circulation. So understanding nature and causes of cyclones is crucial for meteorologists, emergency responders, and coastal communities to prepare for and mitigate the impacts of these powerful tropical storms. Early warning system, forecasting, and preparedness measures are essential components of managing the risk associated with cyclones. So I've put in two diagrams here from NASA and then from the NOAA. You'll see the diagram. We have the wind is created by moving air, which is deflected to the right. You'll see the black arrows, and then the Coriolis effect, that is red arrows, which causes the wind to rotate in a counterclockwise direction around the eye of the hurricane. There's a low there, then there's circulation around the eye. And because the Coriolis effect acts at right angles to the wind direction, Coriolis deflects wind, circling the eye of the storm away from the central low pressure zone, thereby opposing the pressure gradient and sustaining the storm. And then there's another diagram there. There's a vertical exaggeration of the storm, which is where explain these pictures are taken from the internet, one from NASA, in a book by Keller and Dovechu, and then the other one from the NOAA. Now, impacts of cyclones. Now, the impact of cyclones, also known as hurricanes or typhoons, in different regions can be widespread and severe, affecting both coastal and inland areas. The impacts are multifaceted and can result in significant social, economic, and environmental consequences. Here are some of the key impacts. Number one, we have destructive winds. Cyclones are known for their powerful winds, which can reach extremely high speeds, so that's up to 300 kilometers per hour. You can imagine a vehicle moving at maybe 100 kilometers or 120 kilometers per hour hitting a building. And I'm talking of air or wind in motion. This wind causes extensive damage to infrastructure, buildings, and vegetation, leading to widespread destruction. Then we have storm surges. One of the most dangerous aspects of cyclone is the storm surge. The low pressure center of the cyclone, combined with the strong wind, can cause a rise in sea level along coastal areas. So storm surges can lead to flooding, especially in low-lying regions, and result in significant damage to coastal communities. Then cyclones also bring prolonged intense rainfall, leading to flooding. The heavy precipitation can cause rivers to overflow, resulting in flash floods and inundation of urban and rural areas. Floods pose a threat to life, property, and agriculture. Then you have flooding, also landslides. The combination of flooding and landslide, the topography of an area can lead to, flooding and, a combination of heavy rainfall and the topography of an area can lead to flooding and landslide. Landslides in hilly or mountainous regions can pose additional dangers, blocking transportation routes and causing further damage. Then you have tornadoes. Severe cyclones, particularly those with supercells, can spawn tornadoes. Tornadoes are also highly destructive by their high-speed wind and like funnel. They can suck up buildings, suck up cars, and pull out infrastructure and so on, and cause a lot of localized damage within the broader impact zone of the cyclones. Then you have displacement of populations, of course, where there is flooding, where there is landslide, or where the property are destroyed. That leads to displacement of population. Evacuations are necessary to protect the lives, and affected individuals may need temporary shelter and support. Even when there's early warning, because the moment the warning comes, then the onus is on the government to quickly evacuate the people before the disaster strikes. Then we have infrastructure damage, destruction to roads, bridges, power lines, communication networks, and so on. Getting these facilities back takes a lot of money, and it's time consuming. The impact of agriculture, destruction of agricultural land, flattening crops, causing soil erosion, and introducing salt water into arable land. So the loss of crop, livestock has significant economic implications for affected communities. Then you have water contamination, of course, because as the flood comes in, brings in a lot of debris, and then the articles that were pulled in, a lot of surface impurities that were pulled in were contaminated. By the time they flew back into the water will be contaminated, and this can cause risk of waterborne diseases and cause serious public health challenges in the aftermath of the cyclone. Then environmental impact. Cyclones have environmental consequences, including destruction of ecosystems, loss of biodiversity, changes to coastal and marine environment. The influx of storm water runoff can also affect water quality and marine life. Then we have humanitarian challenges. We're talking about displacement of population already. The when population is displaced, of course, challenges come in, emergency, the need for emergency response, Medicare, and aid also come in. So access to affected areas can also be hindered by damaged infrastructure and challenging weather conditions. So understanding the adverse impacts of cyclones is also crucial for disaster preparedness and response and recovery efforts. Early warning systems, evacuation plans, and sustainable infrastructure development contribute to reducing vulnerability of communities to the impact of cyclones. So cyclones are quite, in areas where they occur, they are quite an environmental challenge, a very serious hazard that would lead to disaster, that would lead to loss of millions and billions of money, loss of property, and destruction of the ecosystem entirely. So thank you for listening to this lecture. I will advise you also to go over this over and over. You can pick them from my YouTube channel. Also link up with me on my other social media channels. If you have questions, please drop them in the comment box. I will respond to them appropriately. If you want to communicate with me, please, you are free to communicate with me, ask your questions. I'll be available to answer them. You watch out for my next video. But this does not in any way cancel our physical contact. But I'll be with you. And during the physical contact, please, because you have the video, does not mean you will not, you think that you have known everything. There are a lot of things you hear from me which you may not hear directly from the video. So please make sure that anytime we have physical contact, you are there in class. Thank you and have a pleasant time.